Greetings, mathematicians. In this video, we're going to continue learning about some more exponent properties. The first one here is the power of a quotient. And again, it's what it sounds like. You have a quotient, so a fraction or a division problem, and then raised to a power. And again, this one sort of reminds me of distributing. It's not quite exactly that, but you've got the same values in your numerator and denominator that you did before, but this time you've got the exponent written twice. You've got the exponent applied to both that old numerator and denominator. Same as always, of course, you can't divide by 0, so the value for that denominator cannot be 0. And just as we've done in the past, we'll do this first problem kind of like a longer way, showing the work, and then we'll use the property as sort of a shortcut moving forward. So if we start with this first one, we kind of try to do this a longer way to make sense of this. Remember that squaring means to multiply something by itself. So this would be 3/5 times 3/5. And remember from back in elementary school that when you multiply fractions, you multiply straight across the top and straight across the bottom to get your new numerator and denominator. So you would do the 3 times 3, which is 3 squared, and you do the 5 times 5, which is 5 squared. And that's essentially what this property is saying, is that you would apply the exponent of 2 to both the numerator and the denominator. So the 3 gets squared and the 5 gets squared. Now you could leave your answer like that if you wanted, or since these numbers are not too bad, you can go ahead and square the 3 to get 9 and square the 5 to get 25. Now, moving on. For this next one, we're just going to keep using our new property now, moving on without showing all of the intermittent steps. So we're going to apply this exponent of 2 to both the numerator and the denominator. So the 2a to the 5th will get squared, and the b to the 7th will get squared. Now there's going to be sort of multiple steps of work here, because now I can see that here I have a product property, or a power of a product property. And I need to apply that exponent of 2 to both the 2 and the a to the 5th. In the denominator, I have a power to a power, where I multiply the exponents. In the numerator, again, I can simplify the 2 squared to 4. And then finally here, I have the a to the 5th to the 2nd power. That's the power to a power. And multiply those exponents to get a to the 10th. So then this is my final solution. Moving on, I need to apply the 3 to both the numerator and the denominator. And then in the numerator, I have a power of a product rule, so I'm going to apply to the 3 to both the constant term and this variable term. In the denominator, I just have a power to a power where I keep the same base and I multiply the exponents. In the numerator, I've got 3 cubed, which is 27, and then I've got a to the negative 4th cubed. That's a power to a power again, so I'm going to do negative 4 cubed, or negative 4 to the 3, and then do negative 4 times 3 and get a to the negative 12th. Right, and for my last one, applying the negative 6 exponent to both the numerator and the denominator. The denominator is just a power to a power, so I'm going to keep the same base, and I'm going to multiply the exponents. So negative 11 times negative 6 is positive 66. In the numerator, I'm going to use my product to a power rule and apply the negative 6 exponent to both the a and the b factors. So I've got the a to the negative 2 raised to the negative 6 and the b to the negative 5 raised to the negative 6. Those are both power to a powers, so I keep the bases and I multiply the exponents. And that is my final answer there. So coming up with that one, that's a to the 12th, b to the 30th, over c to the 66. Next up, we have our last two exponent rules. We have the 0 exponent rule, which says that anything other than 0 raised to the 0 power equals 1. The reasoning behind that is looking at somewhat of patterns here. So I've just come up with the list of powers of 2 from positive 2 to negative 2. So like if you're looking at 2 to the first, well, that's 2. 2 squared is 2 times 2, which is 4. And then if you look at like 2 to the negative 1, that would be 1/2, 1/4. And if you kind of think about like what would be missing in between there, if you keep looking at powers of 2, you would end up with a 1 in the middle there. So just kind of going along with the patterns, hopefully that makes somewhat sense of why something raised to the 0 power would be 1. And we mentioned in a previous video a little bit about what happens when you end up with a negative exponent, how it is going to the bottom of a fraction. The reverse would be true as well. If you have a negative exponent in the bottom of a fraction, it essentially goes to the top of a fraction. This is just a way that we rewrite things to eliminate those negative exponents. So we've got a couple of examples here in how we can rewrite some things that have possible 0 or negative exponents and simplifying them further. So let's take a look at this first one here. So if we look at the negative 5y to the negative 2z, the main issue here for this one not being simplified is the y to the negative 2. Now, remember that all of these things are being multiplied, and that if it's not a fraction, it's kind of like it's over 1. So essentially the issue here is the factor of y, and we need to use this last part of our negative exponent, which is it would move to the bottom of the fraction there. So the negative 5 and the z would stay where they are in the top of that fraction, but the y would move to the bottom and the exponent would become positive. For the second problem, the x factor is the part that is the issue. This uses the other part of the negative exponent rule, where basically it's going to move to the top. So the 4 is going to stay where it is in the bottom because the 4 has a positive exponent. That's like 4 to the positive 1. But the x cubed is going to move to the top and the exponent is going to become positive. Now, showing some work on this last one. First of all, this is like a quotient to a power rule. So remembering that everything ends up getting applied to this negative 2, with this negative 2 as the exponent. So this becomes 2x to the negative 2 over 3 to the negative 2. And then that is like having both of those negative exponent rules in the same problem. The 3 in the denominator has a negative exponent, so it goes to the numerator and becomes a positive exponent. The 2x has a negative exponent. It goes to the denominator and becomes a positive exponent. Now we would simplify this one a little further because the 3 squared is 9. And in the denominator, that 2x quantity squared is a product to a power, and we would distribute, or not really distribute, apply that exponent of a 2 to both terms over x squared in the denominator. So last up in this video, there are a couple of practice problems here that I'd like you to try. Go ahead and pause the video and then come back to check your answers when you're finished. All right, so now that you've had a chance to try these, let's take a look. Now remember, you might have different work, but you should end up with the same answer, just depending on what order you chose to apply the different exponent rules. So for the first one, we're using the negative exponent rule twice, once to move the x's to the denominator and once to move the y's to the numerator. Notice we usually don't write the 1 as the exponent, so you probably just have a y rather than a y to the first. For the second one, I rewrote the first set of parentheses with the y in the denominator and the second set with the x factor in the denominator. And then I used what I knew about multiplying, where you multiplied fractions. You multiplied the numerators together to get the new numerator, multiplied the denominators together to get the new denominator. And then I saw that I had a common factor. I had a y squared in the numerator and a y squared in the denominator. And I knew that when you had the same thing like that in both the numerator and the denominator, that they divide out to 1. So essentially they cancel out. And then I've got a quotient rule where I've got the same base, so I know I'm going to keep the same base, and I'm going to subtract the exponents. So 6 minus 13 is negative 7, and then of course a negative exponent means that it ends up moving into the denominator. So I've got an x to the 7 in the denominator. For my next one, the 5 and the 2, they're both going to stay where those are because they have positive exponents. They would be like 1s. But the a term has to move to the denominator and the b term has to move to the numerator. Since they have negative exponents, they have to move their locations. And for the last one, the first thing I did was the product to a power rule, and I applied the negative 2 exponent to all three terms, or all three factors in the first set of parentheses. And then after that, I used the product rule, where I added the exponents. So I kept the same base and then added the exponents to simplify a little further. Then I knew that anything raised to the 0 is 1, so c to the 0 is 1. And the a factor and the b factor both moved to the denominator since they had negative exponents. All right, and then we'll go ahead and we will stop this video for now. And we'll do some more mixed problems where we're combining multiple exponent rules in the next video. So that's it for now. Bye.